So today we're going to talk about double angle identities. And here are your identities. And you have three different identities for cosine. So there, and there. And then you have one for sine and one for tangent. And for cosine, you just use whichever one fits the problem best. Okay, so let's take a look at example number 1. We have cosine of theta equals 3/5, and sine of theta is less than 0. Find sine of 2 theta, cosine theta, and tangent, cosine of 2 theta and tangent of 2 theta. Okay, so we can start off by saying cosine of 2 theta equals 2 times cosine squared theta minus 1, okay? So then we know that cosine of theta is 3/5, and that was squared, cosine squared theta, and then minus 1. So we square the 3/5, and we get 9/25. And since I know I'm in 25ths here, I'll change that to 25/25. Because 1 is the same thing as 25/25. And then we can just multiply. So we have 18 over 25 minus 25 over 25. And so that gives us negative 7/25. So cosine of 2 theta equals negative 7/25. Now let's do sine of 2 theta. So we'll say sine of 2 theta equals 2 sine cosine. All right, so sine of 2 theta equals 2 times sine theta cosine theta. Okay, so we know what cosine theta is. We know that's 3/5. And now we need to figure out what sine of theta is. Well, we know that it's positive, so let's draw a picture real fast here and see what that's going to look like. So, okay, so we know that we're in either the first or the fourth quadrant here because our cosine's positive. And then because sine is less than 0, we have to be in the fourth quadrant because the sine, the y value, has to be negative. So here, let's do this. We'll draw it like that. So we're in the fourth quadrant, right? There's your axes, okay? And we know cosine was 3/5, so our x value is 3. Our r value is r, so that makes our y value negative 4 because it's the Pythagorean triple. So now we know our sine is negative 4/5. Not negative 5/4, negative 4/5. And then we just multiply. So 2 times negative 4 is negative 8 times 3 is 24, negative 24, and over 25. So sine of 2 theta equals negative 25 over 24. Okay, now for tangent of 2 theta, we could fill in these values here. We could find the tangent value and fill them in, or we know that tangent is equal to sine over cosine. So tangent of 2 theta would equal sine of 2 theta over cosine of 2 theta. Well, we just found sine of 2 theta, so that's negative 24 over 25. And then we found cosine before that, so it was negative 7 over 25. Okay? And so, I'll do that. Scroll it up a little. So then we know that the 25s are going to cancel. And then our negatives cancel to give us a positive. So tangent of 2 theta is equal to 24 over 7. So that's how we would apply our double angle identities to solve this problem. All right, example number 2. Find the values of the 6 trig functions of theta if cosine of 2 theta equals 4/5, and we know that theta is in between 90 degrees and 180 degrees. So it's in that second quadrant. And we'll just write that up there. So we know we're in quadrant 2 because it's between 90 and 180. All right, so we want to find the 6 trig functions. Well, we already know what cosine is. So let's take a look at, well, we don't know what cosine is because it's cosine of 2 theta. We need to find cosine of theta. All right, so let's start off by using the cosine of 2 theta. We know that that is the same thing as 2 times the cosine squared theta minus 1. And so we know cosine of 2 theta is 4/5. So now we just use our algebra skills to solve for theta. So first we're going to add 1 to both sides. Okay, and that's really going to give you 9/5 because that's 5/5 plus 4/5. So let's go ahead and make that 9/5. Okay, then we're going to divide both sides by 2. All right, so when you divide this fraction by 2, it's like multiplying by the reciprocal. So it's really 9/5 times 1/2, which gives you 9/10. And then the last step there is to take the square root. And remember, that's got to be plus or minus. All right, so we have the square root of 9, which is 3, over the square root of 10. And that's your cosine of theta. Now remember that plus or minus. Well, we're looking at cosine, and that's the x value, okay? And we know we're in quadrant 2, so our x value has to be negative. So this has to be negative, all right? And then the last thing we need to do is rationalize the answer. So we have negative 3 square root of 10 all over 10. And that's your cosine value, okay? All right, so now what we can do, we can look at some other double angle identities and use those to solve the problem. Or we can take what we found here and draw a picture. So let's say we know we're in quadrant 2, okay? And we know that our x value is negative 3, and our r value is square root of 10. So now we can just use Pythagorean Theorem. Okay, and remember that this angle is theta. Okay, so we know that y squared plus that negative 3 squared equals the square root of 10 squared. So y squared plus 9 equals 10. And so y squared has to equal 1. And because we're in the square root of 1 is 1, and because we're in that second quadrant, the y value is positive, so y has to be positive 1. So now we can go ahead and look at what all of our function values are. All right, remember we already found cosine. So now our sine value of theta is 1 over the square root of 10. And when we rationalize that, we get square root of 10 over 10. So there's the sine value. Our tangent value is going to be y over x, so negative 1/3. Okay? Now let's take a look at our reciprocal identities. So if cosine is negative 3 square root of 10 over 10, or we can go back here and look at the negative 3 square root of 10, that means that secant of theta is going to be negative square root of 10 over 3. Okay? All right? And then we know that if sine is 1 over the square root of 10, then cosecant is going to be square root of 10. Okay? And then if we know that tangent of theta is negative 1/3, then cotangent is the reciprocal of that. So it's going to be negative 3. And so those are all of the 6 trig values for theta in this problem. All right, let's take a look at example 3, and we want to verify this identity. All right, so really we could work either side, but I'm going to work the left-hand side because it looks a little bit more complicated to me. But also, it's going to be a little bit easier to work with because sine of 2x only has one identity, whereas cosine of 2x has 3 different identities that could be used. Now, really, you could work either side, but I'm going to go with the left. All right, so first I'm going to change the cotangent into sine and cosine. So we have cosine of x over sine of x, and then we're going to replace sine of 2x with 2 sine x cosine of x. Okay, so now we can simplify a little bit, and our signs are going to cancel, and we're left with 2 cosine squared x, and we're trying to get it to look like this guy right here. We're almost there. It looks very similar to our cosine of 2x identity. So let's see, what if I do this? 2 cosine squared x plus 1, actually let's say minus 1 plus 1. So what am I really adding here? I'm really adding 0, because I have plus 1 and minus 1. But why did I want to do that? Well, if you take a look at your double angle identities, what does that one equal? Yeah, it equals cosine of 2x. And isn't that the same thing that we were trying to find? Yeah, so we verified it. Let's take a look at example number 4. All right, we want to simplify each expression. And let's take a look at part A. Does this look like one of our identities? Yeah, it looks like cosine of 2 theta. All right, so let's say, or A, or whatever you want to use. So let's call this A. All right, so then this whole thing is cosine of 2A. Well, what was 2A? Or what was A, I mean? A was 7x, so it's 2 times 7x, so it's really cosine of 14x. And that's all you do. All right, now let's take a look at part B. Now this one looks very similar to our sine of 2A. So let's say this is A. Okay? Well, we know sine of 2A equals 2 sine of A cosine of A. Okay? Well, we're almost there, but we have this 2 here. So how can we get rid of that 2? Because it looks almost like this. What can we do with the 2? So we have 1/2 sine of 2A equals sine A cosine A. Well, that's the same thing. This is what we have right here. Well, what was A? 15. So we can just plug A into here. So we have 1/2 sine of 2 times 15, which is 30. And we know what the sine of 30 is, right? Yeah, it's 1/2. So we have 1/2 times 1/2, which is 1/4.